Hello and Assalamualaikum. So today, Group 8 will explain about the adsorption of wastewater treatment.
A very good evening, everyone. We are from Group 8 and we're about to present our group project, which is focusing on the adsorbent. So, the introduction for this adsorbent. Absorption is a surface based process used in wastewater treatment to remove impurities by adhering contaminants into the solid material, typically an absorbent. So there are some specifics absorbent that we will use. The first one is activated carbon, zeolites, agricultural byproducts, and methyl oxides. And the next one is the application of wastewater treatment. Adsorption is apparently has emerged as a critical method for tackling a wide range of pollutant issues in wastewater treatment. It successfully lowers impurities while also ensuring water safety for both the environment and for the humans. So there are organic pollutants including dye and oils, heavy metals like lead, mercury, and cadmium, and other toxic substances. Next is the process description. The first one is going from the abstraction, which is extracting from the sewage water, and then we have the pre-treatment and inlet control, and then move to gas exchange process, and then move down to the flocculation and sedimentation, and then we have this is the oxidation process, and then we have this our core process, which is the filtration and adsorption. The next one is the membrane filtration and reverse osmosis. And the next one, we have the ion exchange. And the next one, we have conditioning and disinfection, which is one of our core process as well. And then the next is the storage and distribution. A very good evening, everyone. So these are the unit operations for the absorbent preparation. So the first one is per-oxidation tank. So the core of the unit is where the contaminants are removed from the water. And the second one, we have the pH correction unit, which the function as to adjust the water's pH to an optimal range to enhance the absorption efficiency. The third one, we have disinfectant unit, which ensure the treated water is free from microbial contaminants. The fourth one, we have waste handling system, which manage to spend absorbent backwash waste and any other bioproducts by proper waste handling to ensure the compliance with the environmental standard and prevent secondary pollution. The fifth one, we have absorbent column, the core unit of this system where the contaminants are removed from the water in a core way. And the sixth one, we have this infectant applicator, which assess absorbing capacity to retain contaminants from the treatment volume. The seventh one, we have water pump that is to maintain the required flow rate and pressure of water through the treatment. The eighth one, we have mixing tank used to mix the water with chemicals such as oxidant and pH adjuster. The ninth one is the filtration tank, which provides an additional level of particulate removal before or after absorption. Next, we have the separation processes. So these are the core processes of absorbent preparation. The first one is the pre-oxidation stage. So this stage is initial step to the absorption process, where oxidants such as ozone, chlorine, or hydrogen peroxide are introduced into raw water. These steps aims to oxidize organic and inorganic contaminants, transforming them into more absorbable form. The next one, we have pre-filtration. So pre-filtration is in order to remove the suspended solids, particulates, and other large impurities from the raw water. These contaminants, is, if not removed, can clog the absorbent column, reducing its efficiency and its lifespan. The third one, we have adsorbent column, which is the core of this process, where the contaminants are removed from the water and the water passes through the packed of bad absorbent materials such as activated carbon, silica gel, or alumina, which traps pollutant to its surface. The choice of adsorbent itself depends on the type of contaminants that to be removed. And the fourth one, we have post-treatment or pH correction disinfection. So, in the post treatment stage, the treated water undergoes final adjustment to ensure the safety and regulatory standards. Additionally, disinfection is also carried out using UV treatment. So, chlorination or other method in order to eliminate any remaining pathogens. These are the cost analysis for the instrument and operational fee. So the first one, we have pre-oxidation tank. We require 2 units for this one, which cost per unit is 1,053, and this is the final cost. This is we have the pH correction unit with the illustration with the image, sorry, and then we have the pre-filtration unit and absorbent column disinfection unit, waste handling system, absorbent material. Next, we have chemicals containing oxidants, alkali, disinfectant applicator. Next, we have water pump. We require 5 units of water pump with different specification. And then we have mixing tank. We have filtration tank, industrial sewage water, and pipe connector. So the last one, we have electricity supply that we are required in order to supply our electricity for these processes, and the amount of electricity needs per day is 1.5 times 10 to the power of 6, or 1.5 million kilowatt hours. So it's equivalent to 600,097,500. So this is the total.
So I'm going to explain about the separation process and unit operation. Adsorption is the process where contaminant, which is the adsorbates, are transferred from an aqueous phase to the surface of a solid absorbent. There are two types of adsorption. The first one is phase adsorption, which is the physical adsorption. Adsorbate binds via weak forces, which is the electrostatic attraction and van der Waals. It is a reversible process. It can form multiple layers, efficient at low temperatures, decreases with higher temperatures. It is fast by exothermic, it releases heat, characterized by reduction in the free energy and entropy. The second one is chemisorption. Chemisorption is a short form for chemical adsorption. The adsorbate forms strong covalent bond with the absorbent. Slower process typically form a single layer, which is the monolayer. It occurs at a high temperature and efficiency increases with temperature until it reaches the peak, then decreases. It is irreversible and highly specific interaction. So these are the operational parameters. The first one is flow rate. Flow rate is used to determine the contact time and process efficiency. The second one is pH level. It affects ionization state of contaminant and adsorbent surface properties. The third one is temperature. It impacts adsorption kinetic and equilibrium. Optimization needed for maximum efficiency. The fourth one is contact time. Adequate interaction time is essential for effective contaminant removal. The fifth one is surface area of adsorbing. Larger surface areas, porous finely structures provide more adsorption sites for a higher efficiency. The sixth one is nature of the adsorbate. High solubility adsorbates tend to have a weaker interaction, reducing adsorption capacity. The seventh one is initial concentration of adsorbate. Low concentration allow higher adsorption efficiency. Saturation limit further absorption at higher concentration. The eighth one is absorbent dosage. Increasing dosage provide more adsorption site, but excessive amount can lead to inefficiencies. The last one is competition among solute. Multiple contaminants can enhance or reduce adsorption efficiency based on interaction. So these are the feed composition of the separation process and unit operation. The first one is feed composition of the adsorption unit. There are pre-treatment steps. The first one is pre-oxidation. It helps to break down the contaminant to make them more easily absorbed. The second one is pH correction. It adjusts the pH to optimize adsorption efficiency and prevent damage to the absorbent. The third one is filtration. It removes large particle and suspended solid to ensure the feed is compatible with the absorbent. The second one is raw water composition. The first point is pharmaceutical contaminant. It includes substances like ibuprofen, antibiotic, hormones, for example, like menstruation blood, due to improper disposal or human excretion. The second point is pesticide. It's chemicals such as atrazine and glyphosate from agricultural runoff. The third point is heavy metal. It includes cadmium, lead, and mercury from industrial discharge, mining activities, and aging infrastructure. The last point is purpose of pre-treatment is to ensure the feed water is optimized for effective adsorption by the column, enhancing contaminant removal and prolonging operational efficiency. So these are the components involved in the adsorption process. The first one is adsorbate. The substance that adheres or stick to the surface of another material, which is the adsorbent. Example including hydrogen, oxygen, or nitrogen. The second one is adsorbent. Adsorbent is a material surface hold or absorb other substances, which is the adsorbates. Example include active carbon, alumina, and silica. The third one is type of adsorbents. There are nature organic adsorbent derived from nature organic material like plant-based adsorbent. There are also nature or inorganic adsorbent, which is naturally occurring in organic materials such as clay and zeolites. There are also synthetic adsorbent, man-made material designed for specific adsorption purposes such as synthetic resins and activated carbon. The application of the adsorption. To remove the emerging contaminant, contain organic molecules such as fertilizer, pharmaceutical hormone, polymers, food ingredients, food preservative, cleaning product, and surfactants. The second one is a benefit, cost-effective and easy to implement method for eliminating new pollutant globally. The adsorbent, activated carbon, modified biocars, nano-adsorbent, and composite adsorbent to extract the water. So these are the target product and purity. The absorbent column target product is treated water that meet quality standard for industrial use, environmental discharge or further processing. The column remove contaminants such as first the pharmaceutical, which is the ibuprofen and antibiotic. The second one is pesticide, which is atrazine and glyphosate. The last one is heavy metal, cadmium, lead, and arsenic. And it also remove organic pollutants such as diphenolic compound. First, the purity of treated water. Contaminant removal efficiency. Adsorption system typically achieve 90 to 99% efficiency depending on the absorbent and condition. Activated carbon can reduce organic pollutant to undetectable level. The second one is the regulatory standard. Environmental discharge must meet the limit for metal, organic pH, for example arsenic, must be less than 10 microgram per liter according to WHO standard. Industrial reuse. Purity depends on specific industry as well as organic and inorganic content. So the purity of the absorbance column operation. The first one is absorbent efficiency. The absorbent typically captures a large portion of contaminant until near saturation. Over time, the absorbent's performance can diminish due to the fouling or saturation necessitating either regeneration or replacement. Another point is the breakthrough point. The purity of the effluent stays high until the breakthrough point is reached, at which contaminant begin to appear in the treated water. Regular monitoring is crucial to ensure the column function within the optimal range to maintain the product purity.
This is a schematic diagram of the unit operation adsorption. For the overview, adsorption is a widely used method for removing pharmaceutical, pesticide, and heavy metal contaminants from the wastewater. It is involved capturing molecules from the liquid phase onto the surface of a solid material. For the challenges with absorbents, absorbent can become saturated with contaminants, hence reducing efficiency and requiring regeneration or replacement. For the selectivity terms, some absorbent may not effectively remove all contaminants, necessitating multiple absorbents and additional treatments. For the benefit, it is have the high efficiency and ease of operation. For the disadvantages, high quality absorbents such as activated carbon can be expensive with additional costs for regeneration or refinement. For the waste management, use absorbent and regeneration byproduct need proper disposal to prevent secondary environmental pollution. For the calculation step, first we write the mass balance overview. Next, we choose the both of the equation, which is to use Langmuir isotherm or Frederick isotherm. For the Langmuir isotherm, Q equal to Q max KLC over 1 over plus KLC. and this is the graph. For the friendly isotherm, Q equal to QFC power of 1 over n, and this is the graph. Next, we've been selecting the absorbent material and packing type. For the next calculation step, we find the design column dimension H equal to QT over A, and then we find the number of stages and efficiency in an absorption column. Next, we find the Murphy tray efficiency. If cases are packed back, find the pressure drop using the ergon equation as below. For cost and reduction, there are several factors influencing the cost. First, the absorbent cost. The price of high quality absorbent such as activated carbon can be quite high. Second, regeneration cost. Third, energy consumption. Maintenance and replacement, waste management, scale of operation, and lastly, for the process inefficiency. The ways to reduce the operating cost without affecting the quality. We can optimize the absorbent usage. Second, we enhance the regeneration efficiency. Third, we improve the system design, minimize waste handling costs, monitor and automate processes, and lastly, we can scale appropriately.
Now let's jump into the conclusion. So, one of the fundamental treatment methods for the effective removal of such organic pollutants, heavy metal, and waste matter is by adsorption. Range of materials, including activated carbon and zeolites, are applied to this adsorption process. In fact, some of the factors influencing this process include surface area, pH, and temperature. The process itself strongly requires careful treatment and proper choice of adsorbent. On the whole, absorption is and will always be viable and sustainable method of wastewater treatment, efficiency of which is strong ensured by the combined process of each research and development.